Hey guys, today we're looking at the surface area of pyramids and cones. So last lesson we looked at the surface area of prisms and cylinders. Today we're going that one step further and we're going to look at pyramids and cones. And technically speaking, a pyramid and a cone are the same thing, right? Because they both have an apex, that's why they're called a pyramid. They have a point that goes up and we just have a different base. Now, pyramids can have different types of bases, like have a rectangular based pyramid, a square based pyramid, a triangular based pyramid, and technically speaking a circular based pyramid, right, which is called a cone. So what is the surface area of pyramids and cones? Well, of all the main pyramids, that means we have a nice sort of shape on the bottom, like a rectangle or a square, or even a triangle. Okay, there's no really set rule for it. Okay, apart from you got to find the areas of all the sides. So if we look at this particular square-based pyramid, I know it's a square because we've got these things here. What we're looking for first of all, the easy one is the area of the base. That's pretty straightforward, right? Because it's just 8 times 8, 8 times 8. But now I have to add on those triangles on the side. Now, with these triangles on the side, we have 4 because it's a square. Every single one's the same. So I've got 4 lots of, which makes this question much easier. The problem is going to be, when I'm looking at that triangle, it's actually looking at that slanted length. So what I'm trying to figure out is, if I look at, I'll do this in maybe green. If I look at my triangle here, okay, the rule for the triangle is half times the base times the perpendicular height. So I actually need to figure out what that length is there. And in fact, if we look at that, that's a right angle triangle there, so that's perpendicular. We also know that that slanted length is the hypotenuse of this triangle in the middle. So I've been given the perpendicular height, which is great if you're doing volume, not great if you're doing surface area, because I need that hypotenuse. Okay, so what I'm now going to look at for this hypotenuse to find out what that length's going to be, you can sort of do it over here in the working. We can say c squared equals, because the hypotenuse, we can say something like 3 squared plus, now that length is 4 squared. So c squared equals 25, so c equals 5. So now I can say half times the base of the whole side, that's 8, times now that perpendicular height of the triangle, that slanted length, and we found out that to be 5, and now I can find out my surface area. 8 times 8 is 64, plus 8 5 to 40, half of 40 is 20, 20 times 4 is 80. Therefore my surface area will be 80 plus 60 is 140, so 144, and that's centimeters squared, and I've got my answer. So you can see it's not that bad, right? It actually isn't. You just have to make sure which length do I have. Do I have the perpendicular height? Great for volume. Or do I have the slant height? Great for surface area. And depending on which one I have, if it's the right one, great. If it's not, let's use Pythagoras. Apart from that, just be clear with your working out. Make it nice and clear. If it's a rectangular based pyramid, kind of sucks a little bit because this triangle's not all the same. You might have those two are the same and those two are the same, so you have to do a bit more working out to find the two different triangles. But apart from that, we often do square based ones, so fingers crossed you can do it. The second example, and I'm only going to do 2 today, is a cone, okay, well, cylinder-based pyramid. Now, of course, with the cone, there's one area we can find really nicely, of course, and that's the area of the base. That's just our pi r squared. Okay, that's nice and easy. But the issue is with this is that we have got this really curved surface area, which is kind of weird. And if I unravel it, it's not going to really be like a rectangle or any other shape. So I actually have to go through another formula. So the formula you have to learn from this is pi r squared plus pi r l, where the L is the slanted length. So in this particular instance, I've got my pi times my 2 squared, because my radius is 2, plus pi times my radius of 2 times, and they've been really nice because they've actually given me the slanted length. We can see that's 10. And so now I can say 4 pi plus 20 pi equals 24 pi meters squared. And that's my final answer, unless, of course, I do some rounding to either decimal places or significant figures. Now, if I was asked to do the volume, you'll see this very shortly, I would have needed to have had the perpendicular height, okay? And there you can see Pythagoras would have come in play. So they might ask the surface area and give you the perpendiculars. You got to use Pythagoras, or it might be vice versa. In this case, we want a surface area that gave us a slanted length, so we're happy as Larry. Have a crack at some more of these questions today, guys. Again, I know that working out can be long and can be a bit monotonous, but please work on your setting out because it'll make life much easier in the long run. Have a wonderful day.